Good evening, Ntando. I've made this video to help you understand what needs to be done in this particular question. They gave you h of x equals 2x plus 7. So that is your function. So if you wrote that as y equals 2x plus 7, and you wanted to plot that particular line, the easiest thing for you to do would be to plot the y-intercept and to plot the x-intercept. Now, the y-intercept we can read off here. We know that that would be 0 and 7. As far as the x-intercept is concerned, we would let y be equal to 0, and then we would need to solve for x. So I'm going to take 2x over to the other side, so that would give me minus 2x is equal to positive 7. Divide both sides by negative 2, and x would be minus 7 over 2. So there I have 2 points, which I can then go and plot on the Cartesian plane, which I think I'm going to have to do on the next page. I don't think I've got enough space here. Then you have to do the inverse of this function. So an inverse function means swapping x with y. Because you're reflecting, essentially what you're doing is you're reflecting it over the line y equals x. So in other words, what we would have ended up doing is we would have ended up saying x equals 2y plus 7, like that. If I bring the 2y over to this side and I bring the x over to the right-hand side, I would then have to divide through by negative 2. So that would give me y equals 1 over 2x minus 7 over 2. And if I did the same thing here, I wanted to record what the x and y intercepts would be. My y-intercept is now what my x-intercept was. X and y have changed around. So I'm now got a y-intercept at minus 7 over 2. If I want to work out what my x-intercept is, again, I'm going to let y be equal to 0. 1 over 2x minus 7 over 2, which then means that if I take the half x over to the other side, I would have minus 1 over 2x equals negative 7 over 2, which means that x has to be equal to 7. All right, and that also makes sense. So now my x-intercept is going to be at 7 and 0. All right, let's go on to a new page and let's sketch these functions so that we're able to have a better idea of how they look. So you're going to have to go on to the next page now, okay? So here we are on the next page. We've got your diagram over here. So far, what I can see is that the way that you have written the inverse of the function, that is correct. But where I'm struggling to follow what it is that you're doing over here is this. I think you're trying to find the point of intersection at this stage over here. But the problem is that this line, being h, is drawn correctly. But this line over here, which is your inverse, is drawn incorrectly. All right, so let's get ourselves a set of axes. All right, like so. And the line h is going to do something like that. All right, and at this point over here, that's 0 and 7. And at this point over here, this is minus 7 over 2 and 0. Now, the line that we are reflecting over is the line y equals x. So that's this line over here. And we have inverted this function. So now when I sketch it, it's now going to look something like this. And that would be 7 and 0. And this over here would be 0 and minus 7 over 2. All right. So the point of intersection takes place here in the third quadrant and not up here in the second quadrant where you had it. Let me also just label my graph. So this is my inverse function over here. And it's always important to label the points on the graph. So in this case, our x and y intercepts. Now, if we want to solve for the point of intersection, we have to let the two functions equal one another. So what I'm going to do is I'm going to let 1 over 2x minus 7 over 2, which is the yellow function, and that needs to be equal to the red function, which I'm now writing in yellow as well, as 2x plus 7. The easiest thing for me to do at this point is multiply through by 2. So I'm going to multiply each term in the equation by 2. in order to get rid of the denominator. So that's going to leave me with x minus 7 equals 4x plus 14. If I bring 4x over to the other side, I end up with x minus 4x equals 14 plus 7. Thus, negative 3x equals 21 and x equals negative 7. And that makes sense because I know that this point has to be in the third quadrant. When I now want to work out the corresponding y-coordinate, I can sub into either one of the two functions. So let me sub into the one where I don't have to work with any fractions. So y equals 2 times negative 7 plus 7. So that is negative 14 plus 7, which gives me negative 7. So this point of intersection, I could call it P if I wanted to, has the coordinates negative 7 and negative 7. That's this point over here. Its coordinates are negative 7 and negative 7. Anyway, I hope that that helped and that you understand what it is that you need to do now. Good luck and well done on all your hard work.